Am I audible? Anyone? Pranoy, Kushi, someone?
Yeah.
Yeah.
You're audible.
Okay, great. So first of all, good evening, everyone. Welcome again to DS404 second session, and we have introduction to data structures and arrays after a compelling session yesterday by Vishrut. Now today we have Pranoy here to tell us more about these fundamental concepts. Again, I would like to just recap quickly what these sessions are about. If you haven't attended our first session, DS404 is a series of sessions conducted by TLE MEC and the TC from where I come from. And we seek to cover these fundamental concepts related to coding. And we hope that you're all educated by the end of this. We'll have future sessions. Right now, the current sessions are yesterday's session and the session that's about to happen now. The timings of future sessions will be updated as soon as possible. If you've registered officially, like I've said before, you'll be able to, and if you complete the tests required, you'll be able to avail the certificates necessary. If you check your mails, you will have received the recorded links or the resources of yesterday's session. And we will be providing the resources of today's as well. So with that, I think we can officially get started, right, Pranay?
Yeah.
Okay, cool. Okay, so with that, I pass it off to Pranoy and hope you all enjoy this. Thank you.
Am I visible?
Yeah, very visible.
Yeah. So hi guys, I'm Pranoy. So in the class CS 5B third year So like before we start this session, like I want to ask everyone like if is anybody like not familiar with data structures? I mean like leave data structures, like not familiar with arrays. So like most of you will be from the computer science background, right? Like in the 12th class. So can you just put in the chat box if you're not familiar with arrays? Okay, and rows. Okay, I just yeah, it's similar to lists. Okay. So there are quite a few. Yeah, so considering them, like this will be a basic session. So like we won't go anything deep to like we won't like cover predefined functions, etc. Like we'll just cover the basic theory and we'll do some problems at the end. So like so let's start the session. So yeah. So what will be covered in this session, like what are data structures, why are they used and its types, applications of different data structures, introduction to arrays, application of arrays. And as I've said before, like we'll do 2 CP problems, like competitive programming problems in HackerRank. So one will be easy level and one will be medium level. So like considering the second and the fourth topic, like you need not focus on that, like just dry theory, like it's just for the formality that I have added to this session. So yeah. So let's start the session. So first one is data structures. So speaking about data structures, like every computer program, like it's a combination of algorithm and data structures. So like algorithm, speaking about the algorithm, like it will tell us how the data will be used. So and speaking about data structures, it tells us how the data is stored and like also their relationship existing between different data. So yeah, the second point is like the definition. So go to the next slide. So yeah, speaking about types of data structures, like the important one is non-primitive data structure. Like we need to learn only that for like our future competitive programming ventures. So considering like the primitive data structure is not that important. So like as we go down to non-primitive data structure, like it's of 2 types, like linear and non-linear. So linear means like that the data elements or values will be arranged one after the another, like in a linear fashion. And in considering the non-linear, like there will be like data elements will be arranged in non-linear fashion, like it need not be like arranged one after the other, like it can be like related to like in a random way, like if one element can be related to 2 or more elements, like that. See, considering the types, you can just guess now, like if it's a tree, like it will be a hierarchical arrangement, and if it's a graph, like graph I'll tell you afterwards. So speaking about linear non-primitive data structure, like there will be two types, like static and dynamic. So they are different in such a way that like their size cannot be changed during runtime. I mean, whether it can be changed or not. So speaking about static, the only data structure is array. So the size cannot be changed during runtime. So yeah. So speaking about dynamic, like there are three types: linked list, stack, and queue, which I'll explain further in the coming slides. So yeah, yeah. So we'll go to the next slide. Yeah. So this is the dry theory. Like I know it's boring, but still we'll go through it just basically. So speaking about primitive data structures, like these are operated by machine instructions. Like basically the data types is itself called the primitive data structures, like int, float. Like int is for integer, storing integer values like 1 2 3 4 5, and like float data structure is used to store like one, like floating point numbers, like one which numbers which will have decimal part. So like 1.23 or 4.56, etc., etc. And pointer, speaking about pointer, it is used to store address of a particular value or a variable. Like we will not store like the dry values like 1 2 3, etc., but instead we'll store like the address locations, like the address of a particular location or a value. So speaking about non-primitive data structures, like these are derived from primitive data structures, and like they always deals with homogeneous and heterogeneous data storage, like yeah, like that. So examples are arrays and linked lists, etc. So going to the next slide. So speaking about types of primitive data structures, as I have said before, like integer, float, character, pointer. Like character means that in alphabets, like can be alphabets or numbers also, like A, B, C, D, or 1, 2, 3, whatever it is. And pointer, as I have said before, it's used to store the address of particular variables which contain data values, etc., etc. So yeah, now any doubts till now? Anything not clear till what I've said? Just put in the chat box. Okay. Okay, so I think it's all clear to everyone. Yeah. So yeah, coming to non-primitive data structures, like as you have said, seen the previous slide, it's derived from primitive data structures. Like this contains, this were like you have seen the flowchart now, like the linear and non-linear. Like linear will be like of two types based on like whether we can change the size of that data structure or not during the runtime. Like when we run the program, that size of the data structure, like whether it can be changed or not. Like if it's changeable, it's static. If it's not changed, like if it's not possible to change, then it's dynamic. So yeah, like linear data structure, static one is called array, and dynamics linked list, stack, and queue. We'll see in the coming slides. And then comes the non-linear data structure. So like the second like as you've seen in the flowchart, it's graph and tree. So we'll see about that in detail in coming slides. Yeah, so let's get to the first linear data structure, that is a static data structure, arrays. So like it will be used to store, like it is used to store homogeneous data. Like we can only store like data of different values of the same type. Like we can store multiple values of the same type. Like for example, if it's an integer array, like we can only store int values like 1, like 1 2 3 4 5 6 7 8, like that. But we cannot store like one like first in the first index, like it will be 1, and second index will be letter A, like that. We cannot store like that. We can only store one type, like integer or floating point or character or string. String means like the whole words, a group of characters, a string. I mentioned in the previous slide, sorry for that. So yeah, speaking about arrays, like arrays will contain indexes, like in each index, like one value can be only stored. Like multiple values cannot be stored in a particular index. So yeah, for each array, like the index values will be ranging from 0 to size minus 1. Like size means the size of the array. Like for an array, there will be size now. Like if it's a array of size 5, the index values will be ranging from 0 to 4. Okay. So the first index will not be index 1, but instead it will be index 0. So don't confuse with that. So yeah, and the data values will be referenced by index values. Like if you want to call the second element, so it will be like index. It will be stored in index value 1 now. Like index value will be starting from 0. So the second element will be stored in index value 1. So it will be yeah, we can access from by calling that particular index. Yeah. So as I have said before, like size of the array cannot be changed during runtime. Like once it's declared, it cannot be changed. Like if we have declared size of the array to be 5, we cannot make it 6 during runtime. Okay, while running the program. So let's go. That's it for the arrays. Like basic part, we'll go deep. Like the code part, we'll see in the coming slides. Yeah. So coming to the next data structure, like I think you're getting bored. Like it's all dry theory now. So just bear me for a few moments. So like speaking about dynamic data structure, that the first one is linked list. Yeah. So speaking about linked list, like in this type of data structure, the data values will be stored in nodes. Like node means it's a storage space. Like and every node, like it'll have two fields, like two parts. Like one will be an address field, and second one will be the data field. So in the data field, we will be storing the value to be stored. Like for example, consider this figure. Like we want to store the value A. So A is the data we want to store. So we'll store in the data field. And the second box now, like in the first node, in the second box is called the address field. And the address field, it contains the address to the next node. Like in special cases and all, it contains address to the previous node and all. Like we'll come into that. So for now, like just consider that the address field will contain the address of the next node. So like you can see in the figure, like there's a arrow called head. Like head is a pointer. Like pointer, as I've said before, it's used to store address of a particular variable or a location. So like the first node will be referenced by the head. So head pointer will contain the address of the first node. So like yeah, we need to access the first node now. So like we need to access through the head. And then as you can see in the figure, like the address field of the last node will be null. Like yeah, will be null. And the difference between array and linked list is that like array, we can randomly access elements. Like if you want to access the fifth element and all during runtime, like we need to just write the particular code for that. But in linked list and all, we cannot randomly access the like access certain elements. Like if you want to in this figure, like if you want to access the like third element, which is C, like we cannot access like using simple code. We need to first traverse. Like traverse means go pass one node after the other, like travel through the nodes and reach to the particular location. Like for example, in the traversal part, like first we'll start from the first node. Like if you want to access the C node, like first we'll start from the A node, then go to the B node, then reach the C node. So this is how we'll access the certain elements in linked list. So that's it for the linked list. Like more stuff will be taught in the coming sessions. So yeah, now let's go to the next data structure. Yeah, I'm sorry. Types of linked list is left. Okay, yeah. Speaking about types of linked list, like there are 4 types, as you can see: singly linked list, doubly linked list, circular linked list, and circular doubly linked lists. So speaking about that, like singly linked list, as you've seen in the previous slide, yeah, this is a singly linked list. So singly linked list means like in each node there will be only 2 parts, that is one address node and one data part. Sorry, not node. Like each node will contain 2 parts, that is data part and address part. So address part will contain the address of the next node, and likewise it will contain like that. Yeah. Now coming to the doubly linked list, the difference between singly and doubly linked list is that like in doubly linked list, each node will have 2 address fields. That is, like in single linked list, we cannot like once we like as I've said before, like for the accessing the C part, like we need to go from A, then to B, then to C. So once if like we have moved from A to B, we cannot go back to A in single linked list. Understood? So like yeah. So in the case of doubly linked list, since there are two address fields, like one address field like carries the address to the next node, but the second address field will carry address to the previous node. So like in this case, if this was a doubly linked list, like if you have reached node C, like the current location is node C, and we want to access node B, then it's possible in doubly linked list, but not possible in singly linked lists. Okay. Okay, then that's it for that. And yeah, then coming to circular linked list. Circular linked list means like the linked list will be arranged in a circular fashion. Like the last node will be connected to the first node. Like see this figure. If this was a circular linked list, like the last node address part is null now. Like that won't be null. Instead, that address the node D address part will point to node A. Okay, so that is how circular linked list works. So then coming to circular doubly linked list, so like it's self-explanatory. So like it will have characteristics of both circular linked lists and and doubly linked lists. And speak like in circular doubly linked list, the last node will be connected to the first node, and also each node will have two address fields. Like we can access the previous node and the next node from the current node. Okay, so any doubts till now? Is everything clear? Do put in the chat. I hope I'm not fast. Okay. See, if my pace is like it's a bit fast, do put in the chats, okay? Or like unmute yourself and tell it's okay. Yeah. So that's it for the types of linked lists. Now coming for like the next data structure, it's also linear. So linear means like right, as I've said before, like linear elements are arranged in the linear fashion. Yeah. Theory, yeah. So speaking about stack, which is a dynamic. Dynamic means the size of the stack can be changed during runtime. Okay, so and also it's linear. So like data values are arranged in a linear fashion. So speaking about stack, like let's consider a real life example. Like in the shelf and all, like we'll stack books now. So like we'll stack one book or the other, like one on top of the other. And like the same way this data structure also works. Like we'll stack one element over the other. Okay. And also if we want to access one random element, like we need to remove, like if there are 5 elements, and like we need to access the second element from the bottom, so we need to remove the top elements and all and we need to access the second element. Okay, we need to remove the elements over the second element. Like if there are the element 3, 4, 5, we need to remove from the top, and then we need to access the second element. So like yeah, that's how the stack works. So yeah, it's an ordered collection of elements like arrays, but as a special feature allows insertion and deletion of elements only through one end. Yeah, so this means that like in a stack, like we can only insert and delete elements from one end, that is from the top of the stack. Like considering, like comparing with the stack of books, like when we want to put a new book on the stack, like we place it on the top of the stack and not at the bottom or in between. Okay, in general case. So yeah, and also if you want to remove one book, like we will take it from the top. Okay. Yeah, so that is how the stack works. And also yeah, here also there's one thing called a pointer also is present here. It can be a pointer or a variable. So the pointer will be pointing to the top of the stack, like topmost element. Okay, if there are five elements, the fifth element on the towards the fifth element, the pointer will be pointing. Okay, so yeah, that's it for the stack. Like and you can see the last point, like insertion and deletion follows LIFO method. Like LIFO method means last in first out. Like the last element to be added will be the first element to be removed. Like if there are 3 books, like the topmost book will be the first to be removed. Okay, like, and also that was the last element to be added also. Okay, so that is how LIFO works. So that's it for the stack part. Yeah, and also coming to the operations on stack, like there are 3 types of operations, like push, pop, and peek. So yeah, push is for to add a new data value to the top of the stack and also update the top pointer. Okay, like we need to update the top pointer each time we add or remove an element to the top of the stack. Okay, pop is to delete a value from the top of the stack and further decrement the top pointer. Okay, and peek is to just return the topmost value, okay, to which the top pointer is pointing. And yeah, stack can be implemented using arrays and pointers. Like arrays means like the size of the stack cannot be changed during runtime, whereas using pointers means like we can change the size of the stack. Okay, yeah. Yeah, so this is like 2 images of the stack. So as you can see, like if this 1 2 3 4 5 yeah, six spaces, so we can push from the top, and yeah, and also the top pointer will be pointing to the top of the stack, and also pop from the top. And considering this case, like this means like in the right image, as you can see, like this here the stack is implemented using I mean like a variable, because as you can see the top a top pointer now, like the top pointer is like initially it's set to -1. That means if the top pointer is -1, which indicates stack is empty. Okay, so if we want to add a new element to the top of the stack, each time we'll increment the top pointer. So initially if we want to add the element 10, so we'll increment the top to 0. Okay, top to 0 means top equal to 0 means there is one element in the stack. Okay, so if you want to likewise if you want to add a new element 20 to the stack, we'll add about 10 and also increment the top pointer. Okay, so that is how stack works. Yeah, now comes the queue part. So yeah, so like the stack, okay, queue is self-explanatory. Like considering the another real life situation, like in cinema theaters and all, like we stand in queues to get the ticket now. So like each time like we'll form a queue, and each time a new person has to wants a ticket, like he has to stand at the back. Okay, and also once the person at the front gets a ticket, the person gets he leaves the queue from the front. Okay, leaves the queue from the front. So that is how the queue data structure also works. So we add the elements from one end and also remove the elements from the other end. Okay, not from the same end, like in stack. In the case of stack, like we add and remove elements from the same end. Okay, but in the case of queue, we add and remove elements from 2 different ends. Okay, so here the elements are queued one behind the other, and also there will be 2 pointers, like 2 pointers pointing to both the ends of the stack. Okay, and they will be generally called front and rear. The front pointer will be pointing to the front, like the frontmost element, and the rear pointer will be pointing to the rearmost element, like the last element. Okay, so yeah, and also in the case of queue, like it'll follow the FIFO method. So FIFO method means like first in first out. Like the first element to be added to the queue will be the first element to be removed from the queue. Like in the considering the real life scenario, like in the like when we all stand in the queue, like the first person to reach like form the queue will be the first person to leave the queue. Okay, so that's how the stack works. I mean queue works. Yeah, so I think we can. Yeah, so speaking about queue, like the main operations are like these are NQ and DQ. NQ means to basically like it means that to add a data value to the rear of the queue and update the rear pointer. Okay, and DQ means to remove the data value from the front of the queue and update the front pointer. Like it's self-explanatory. So speaking about types of queue, circular queue. Circular queue means like the front and rear pointer are connected. Okay, and speaking about priority queue means elements are manipulated, that is added and removed based on their priority. Okay, each element will have a particular priority, and based on that, they will be added or removed to the queue. And deck or DQ means like in case of normal queue, like we can add elements from one end and delete elements from the other end. In the case of deck or DQ, like the additional removing operation can be like the NQ and DQ operation can be done from both the ends. Okay, like there is no particular unit dedicated to like a particular operation. Yeah, so that's it for queues. So yeah, you can see this image like NQ, like we add to the back of the queue. DQ means remove from the front of the queue. Yeah, so this is how stack works. So yeah, you can see this animation, like we remove from the top of the queue stack. Yeah, now queue, like first V comes, W comes, X comes. Now V goes, W goes, X goes. Yeah, then again Y comes, it goes to the back of the queue, like that. Z comes back of the queue. Yeah, this is how the queue works. So yeah, so hope you're all like no doubts till now. Okay, so we'll go to the next data structure, which is nonlinear data structure. Nonlinear means like the elements are not arranged in a linear fashion. Okay, so like elements are like they will be arranged in random fashion. Like in this case of tree, like as you can see in the figure, it will be stored in a hierarchical fashion. Okay, so like ancestral, like that. So coming about speaking about nonlinear data structure tree. So like there will be a special type of like here also it is, the data are stored in nodes, and these nodes will be connected to like they will be connected to other nodes like in a random fashion, like in a hierarchical fashion. Okay, so there will be parent nodes and child nodes respectively, as you can see the figure. So the topmost node that will be called the root node. Okay, so that's it. And also the parent node, yeah, it's self-explanatory now. Like so the parent node will have the child node, and the child node, like two child nodes will have the same parent node. And if the two child nodes have the same parent node, they will be called siblings. F and G are siblings. And if there are no, if a particular node has no child nodes, then it's called a leaf node. In this figure, like F, the node F is a leaf node. And yeah, and speaking about subtree, yeah, it's basically this part is called a subtree. Means like the parent node is not the root node, but also just children. Okay, so it's called a subtree. So yeah, so about the boring theory about trees, and like the elements may or may not be arranged in a sorted order and stored in nodes. Yeah, this about the basic theory. See, these slides will be shared after the session, so you can go through this according to your convenience. So yeah, that's it for trees. And speaking about graphs, like it's not a like here it's like in a also the elements are arranged in a random fashion, but not in a hierarchical way. Not in a hierarchical way. So yeah, based on some conditions. And also there are two types of graph, that is undirected graph and directed graph. Undirected graph means there is no direction between this nodes. Like here also the data will be stored in nodes, but there is no direction existing between them. Okay, so seeing this figure, like every graph, see, I forgot to tell you something, like considering this graph, like every graph has a set of vertices and edges. So like here the set of vertices, like in this left graph, the set of vertices will be A, B, C, D, E, and the edges will be A, B, and B, D, like that. Okay, so if the edges does not have a direction, then it's called an undirected graph. If the edges do have a direction, like in the right graph, you can see like the edge between A and B, like there's a direction from A to B. So it's called a directed graph. Okay, so like in the definition of the data structure, I've told you now, like it's also used to represent the relations. So like in here also we can notice like we can represent the relation between A and B by using that direction. Okay, so that's how it works. Oh, sorry. Yeah. So yeah, so about the dry theory about the graph. So graph can be represented as G is equal to V comma E, where V is the set of vertices and E is the set of edges. And yeah, like that. And types of graph: directed graph, non-directed graph, and connected graph. Connected graph means like between every pair of nodes there is an edge. Okay. Non-connected graph means like between some pair of nodes there may not be an edge. Okay. Like that. Why should we store data in such a complicated way in tree? Like we need to represent the relations now. Like in particular cases, we need to represent relations. Like it's not as complicated as you think. Okay, like in particular cases and all, like these are some of the most optimal ways to store data. Like when you like get to learn the code, like you'll understand. So yeah, this is the applications of different data structures like linear and non-linear, like that. Applications of, yeah. So speaking about linear arrays, like it's for CPU scheduling. Like speaking about CPU scheduling, those who like, I'll give you the basic definition. Like the CPU processor should be allocated to different processes in the computer. So like the different information about the processes need to be stored inside arrays. Okay, like multiple arrays, like the process execution time, like that. Okay, so we use arrays for that. And sorting operations, yeah, like self-explanatory. Like we like a particular set of numbers need to be sorted, then we need to store in the arrays. And linked list, yeah, these and all, like you can refer it afterwards. So yeah, so that's it for data structures. Now it's time for arrays in specific. Yeah, so let's all start with the question. Like let me know how many of you do remember about arrays. So can you answer this in the chat? Don't be anonymous. Like yeah. So yeah, most of them do remember about this. Yeah, so this A is the correct answer. Yeah, so for those who don't know, like we'll get into that. So speaking about arrays, so this is the main part of this session. So like yeah, so as I've said before, like this is a linear static data structure which stores homogeneous data, which means like the elements are stored in a linear fashion, and also the size of the array cannot be changed during runtime, and also the only one type of data, that means whether be it integer or floating point or characters. Okay, we can only store one type of data inside one array. Okay, and also yeah, static because size cannot be changed during runtime. Yeah, that I said before. Yeah, so and yeah, speaking about the dimensions, like arrays can be one dimensional, two dimensional, or multi-dimensional. Like it means that like if it's one dimensional, like the elements will be arranged in linear fashion, and like if it's two dimensional, like there will be arrays within arrays. Okay, like there will be sub arrays. Okay, so if it's three dimensional, like there will be arrays within arrays within arrays. Okay, so like hope you have understood, like goes like that. So like we can have multi-dimensional arrays. So, and the last point I've said before, like the index value of the array goes from 0 to n-1 considering the size of the arrays n. Okay, so yeah, that's it. So yeah, Now for those, like from this part, like it will be important for those who don't know about arrays. So speaking about syntax, like the 1D arrays, like the first, considering the first syntax. Syntax means like the way in which we write the code. Okay, the format. Okay, speaking about the format. So the 1D arrays, as I've said before, like it's like elements are arranged in a linear fashion. There is no sub arrays. Okay, if it's 2D arrays or 3D arrays, then like there will be arrays within arrays. Okay, I'll explain that later. So syntax of 1D arrays, like considering the first syntax, data type. Yeah, first we'll write the data type, like be it int or like if it's integer, we'll write int first, like int. Then if it's a character, we'll write char. Okay, char. Then if it's a floating point array, we'll write float. Okay, float. Okay, then comes the array name. Like we can name the arrays like as we want, but we cannot give a keyword names for arrays. Keywords means like these are specially reserved words for specified functions. Like I think in the previous session Vishnu might have introduced to you. So yeah, so we cannot give keywords as names for arrays. So then we'll in the square brackets we'll specify its size. Okay, so be it 5 or 10 or like anything, it can be anything, but it should be greater than 0. Okay. So speaking about the second syntax, first one will be data type conventionally, and then comes the array name, and then comes like we need not specify the size, but we will specify the element values. Okay, in curly braces. Okay, in those brackets will specify the values. Like here we need not specify the size, but we will specify the values. Okay, so automatically we will be counted. But here also we cannot change the size of the array during runtime. Okay, hope you have understood. So then comes the third syntax. So third syntax means, yeah, conventionally like we are also like we are declaring the array by initializing. Initializing means like we are giving we are declaring the values of elements in the code, like in the declaration itself. So yeah, first one is conventionally the data type, then the array name, then in brackets we specify the size, and equal to in curly braces we specify the values. Okay, but here the problem is like in the second syntax, like we can in the curly braces we can specify as many values as we want, because we are not specified the size. In the third syntax, like if the size is 5, okay, if the size is 5, we can, in the curly braces there should be only 5 or less than 5 number of values. Okay, if there are 6 values, then it will show error. Okay, when it's compiling, during the compiling time, it will show error. Okay, so that's it for the syntax of 1D arrays. Yeah, now comes the 2D arrays. So speaking about 2D arrays, like the conventional, first of all, it's the data type, be it int or float or char or whatever it is. Then comes the array name, and then comes the dimension size 1 and dimension size 2. Like hope you know, like are you guys familiar with matrix? Like you know what's matrix now? Is anybody not familiar with matrix? Like 2 cross 2. Can you put in the chats if anybody's not familiar? Okay, I think everybody's familiar with matrix, so I'll proceed. So yeah, so in the considering the matrix, like if it's a 2 cross 2 array, then there will be like rows and columns now. Like there will be rows and columns. So like there will be like first row, second row, third row. So the first one will be the first dimension size now will be in the number of rows, and the second dimension will be the number of columns. Okay, so we will like access the elements in the 2D array by specifying the row number and the column number. Okay, but also the index also in this case also the index starts from 0 and goes up to size -1. Okay, so if yeah, so explained before. So coming to the second syntax is a multi-dimensional array syntax. So first one is data type, then array name, then comes the dimension size 1, 2, 3 up to it goes like that. So yeah, that's it for the multi-dimensional. It's not that important. Like in the CP like competitive programming, like at most we use 3-dimensional. Like the higher dimensional arrays are like less used. So you need not worry about that. Like as per my knowledge. Okay. So speaking about examples, yeah. So the first example is like the syntax for 1D array. The second example is the syntax like for 1D array itself, but we have not specified the size. But the size, like, okay, can you guys tell me like what's the size of the array in second syntax in the chats? Four, yeah, that's right. So here, like we can, yeah, that's right. So here, like we can like add more data values to the array, but we cannot add more data values if like in that square brackets now. Like if there is one value specified in that square brackets, then in the curly braces we cannot add elements, number of elements more than that specified value in that boxes. Okay, like as you have said in the previous slide, like the third syntax, this one. Yeah, this one. This third syntax, we cannot the number of elements should in the curly braces should not be greater than size. That square brackets. Okay, hope you have understood. So yeah, so any doubt till now? Please do let me know in the chats. Is the declaration same in all programming language? No, it's not. It's not same. Like in Python and all. Yeah, I forgot to tell you that in Python and all, arrays is called as lists. Okay, it's not called arrays. And also the declaration means it's very simple. Like there is no like in Python and all, there is no data type. Okay, yeah, exactly. Aithan has showed us like that's how we declare an array in Python. Okay, it's as simple as this. Like we need not specify the data type. Okay, like Aithan has declared a empty array. So yeah, that's it. So any other doubts? Okay, I think can proceed. So yeah, can all of you just try this question? The basic one. No answers. No, it's not B. Yeah, I just said the right answer. AI or AL. Okay. No, it's not D. The answer is A. Yeah. So anybody care to explain this question by unmuting themselves? Anyone? Okay, I think nobody's ready. Okay, so I'll explain this myself. Okay, so let's read this question. A program P reads in 500 integers in the range 0 to 100, representing the scores of 500 students. it then prints the frequency of each score above 50. What would be the best way for P to store the frequencies? Okay, so considering this case, like there are 500 entries. Okay, each entry is the marks of 500 students. Okay, and each mark is in the range 0 to 100. So like what should be the array size to store the frequency of each score above 50? Okay, that is the question. So like since the range is from 0 to 100, so the number of possible entries which need to be stored will be from 50 to 100. Okay, so the number of values, like whose which the count should be like, sorry, 1 second. Q only requires us to store the frequencies. The Q only requires us to store the frequencies associated with each score greater than 50. Yeah, I mean, what's Q? Did you mean P? Oh, question. Okay, fine. Yeah, so it requires us to only store frequencies of values above 50. Okay, as AI has said to us, like, do check in the chats. Okay, so yeah, so like we need to check the frequencies of the marks from 50 to 100 only. So we need to declare an array of size 50 only. Okay, so hope you have understood. Like if anybody has still not understood, like please let me know in the chats. Okay, I think everyone has understood. So let us proceed. So yeah, now comes the, like, till now we have studied about the declaration of arrays. Now comes the traversal and insertion of elements into the array. Traversal means like we need to access and accessing of arrays, elements in arrays, and also like we need to pass from one element to another in an array. That's called traversal. Okay, the movement through the elements is called traversal. Okay, so particularly there are two methods by which we can enter elements to the array. The first one is manually entering elements by choosing the index value. So like, for example, if there is an array, so int a of 5. Okay, so if you want to enter an element value 6 to the second index, so we will write the code as a of 2. I mean, sorry, if the index is if the second index, if the second index we want to store an element 6, we will write the code as a of 2 equal to 6. Okay, and semicolon. So the seeing the syntax also you can understand from that. We'll first specify the array name equal to the value we need to store. Oh, sorry guys, like there's a mistake here. It's do check the chats. Chat box. Array name. The syntax is array name index value equal to value. Okay. Yeah. This is the correct syntax. The syntax in the slide is a bit wrong, so pardon me for that. So yeah, I'll rectify it and share it with you. So yeah, array name, then the index value equal to value. That's the syntax for entering an element to the array. Okay, to a particular index. Okay, so this method is used. Okay, so generally, like initially, if the array is empty, we don't use this method to enter the elements to the array. Okay, like if the generally we use this method when the array is full and we need to update the elements inside the array. So that is the method we use. Like this method is used there in that particular situation. So now coming to the second part, that is through iteration. I mean, sorry, example code for the first method. Yeah, so hash include, this is the header file, hash include stdio.h. So header files are like used to tell the compiler to start the input output operations. Yeah, hash include stdio dot h is for that. Then void main, the main function. Then the first part is self-explanatory now. Int a bracket, that's the syntax which I have said before for declaring an array. So cout a of 1, this is the printing of array. So output will be 6. So we have output the value 6 in the first index, that is value 6. Then we need to update the value in index 1 to 10. So we have written the code as a of 1 equal to 10. So again, if we try to output the value in the first index, then it will be 10. Okay, hope you have understood. So yeah, that's the next way. Now coming to the second method, like iterating and traversing through each, like second method is iterating and traversing. That means we'll use a loop like many of you have heard, like many of you remember like for loop, while loop, those kind of things. We use those two loops to iterate through the array. So yeah, so generally we use for loop or while loop to iterate through the array and add elements. Okay, so syntax is like assume an array of size n exists with no elements in it, like an empty element of size n we have declared int a of n. Okay, we have declared like that, and then we need to add elements to it. So we use the for loop. Then like this is not a syntax, this is the actual code. So syntax, it's basically understandable, like for int I is equal to 0. I is the iterator. Iterator is the variable which passes through each index. Okay, we need to access each index now. So the iterator helps to access each index inside the array. Okay, so int I is equal to 0. Iterator is set to 0. So since first index in the array is 0, 0th index, so iterator is set to 0. Then I is less than n, I plus plus. So I will loop to I equal to n minus 1. Okay, so each time during each iteration, like it will be the I value will be incremented. So that is how the for loop works. And each time when we access, like for example, consider the first case, for int I is equal to 0, I is less than n, 0 is less than n, it's true. Okay, consider if n is some 5. Okay, then I plus plus. Okay, so we get inside the for loop. Then we do cin. Cin statement is used to input numbers in C++. Okay, cin statement a of I. So that is how we input elements to the particular index. Okay, so if considering this situation, the I value is 0, so we take the input from the user and store it to the 0th index, a of 0. That is how the addition works. So considering the while loop, so while loop assume an array a of size n, we declare an iterator I outside the loop. So here in the case of for loop, we can declare the iterator in the syntax itself, but in the while loop, the iterator I should be declared outside the loop. Okay, there is no inbuilt iterator for while loop. Okay, so yeah, we have initialized the array a of n, that's self-explanatory. Second line also self-explanatory, int I is equal to 0. So iterator declared and initialized to 0. So then while loop starts. So while loop is it's an entry control loop. So first it checks the condition, and if it's true, it gets inside the loop. Okay, so each time it gets inside the loop, it takes the input from the user and store it to the ith index, c in a of I, and then I plus plus to increment the iterator. And when at the end of the, like when I becomes n minus 1, okay, then the last iteration happens, and then if I becomes equal to n, then it exits out of the loop, because if because I is not less than n now. If I is equal to n, I less than n is not true. Okay, so it'll come out of the loop. So that's it for, yeah, so that's it for storing. Now printing elements of the array, somebody has put in the chats. Okay. So same method for entering elements. Yeah, so the difference is that instead of, yeah, so printing statement like elements of array, we use the same loops like for loop and while loop, but instead of using cin statement, we'll use cout statement. Okay, like in the previous code, I'll show you previous code. Like in the for loop, if you want to print the elements, instead of the cin statement, we'll just use the cout statement. Okay, so that's it, printing elements. Yeah, so this is the example code. Yeah, so cout is self-explanatory, so you can refer it afterwards. Yeah, so some of you might have elements in a 2D array. So now we come to the section of 2D array. So this is like the first syntax is self-explanatory. So see like we have declared a 3x3 array. Okay, three rows and 3 columns array. But in the square brackets we have entered the elements. I mean, sorry, not square brackets, curly brackets. We have entered the values in a linear fashion, but that's not a problem because the compiler, like, it takes the first 3 elements and add it to the first row and next 3 elements to the second row, like that. Okay, we need not specify like in the subarrays and all. So in some variable is initialized to 0, then for loop starts. Okay, so here if we want to access, like, we need to use nested. Nested means for loop inside a for loop, nested for loops. Okay, we need to use that. So like first of all, like if you want to access the element in the first row and the first column. Okay, for the first row and the first column, the index value will be 0, 0. Okay, like in the matrix you have known, now, like 0, 0, 0, 1, 0, 2, like that. So the outer for loop, first, like the outer for loop is for accessing the rows and the inner for loop is for accessing the columns. Okay, like first, like we'll add the elements like this. Like first row will add the 3 elements, next row we add the 3 elements, like that. Okay, so here we need to calculate the sum. So initially we have set the sum to 0, and then inside the inner for loop we update the sum. Okay, initially the sum is 0 and we update it with each element in each index. Okay, we'll add each element in each index to the sum variable. Okay, that's how sum is calculated. So at last sum is printed. Yeah, so that's it for sum of elements in 2D array. So yeah, can you all solve this question and put the answers in the chats? So this is a simple question. Hope you all get it. So v of I comma j is used to reference a particular element. Like v of 0, 0 is used to reference the first element, like first element in the first row in the first column. Okay, like that. Yeah, guys, I've been told like those who haven't registered for the session need to register to avail the certificate. So please do that if you're not done yet. Yes, the answer is a yeah. 0, yeah. That's the right answer. Yeah, most of you have solved it. That's good to see. Yeah. So yeah, coming to the application of arrays, yeah. So this is the CPU scheduling, as I've said before. Then the sorting operations, matrix calculations. Yeah. So basically, this is a matrix, like 3x3 matrix. So we need to calculate the sum of elements in this matrix. So yeah, this is a matrix operation. So this is an application of array. Okay. So yeah, and database records are implemented using arrays. Yeah, so like try theory. We need not look into that much. So yeah, we are done with theory. So time for solving some CPU problems. So let's get started with hacker rank. Yeah, so here is my screen visible? Like, can you let me know in the chats? Okay, okay. So yeah, let's start with this. Start with the question. So the first question. So this is an easy level question. So the first question is like to reverse an array. Okay, an array will be given and we need to reverse the order of its elements. Like if the given array is 1, 2, 3, 4, 5, we need to make it 5, 4, 3, 2, 1. Okay, so basically there are 2 approaches to solve this problem. Like this problem I'll explain to you in detail, and next problem, like I'll ask you like your approach in the chats. So speaking about this problem, like there are two approaches. Either you can create a new array and then we'll iterate in the first array, like the given array, we'll iterate through it and we'll start the iteration from the last element. Okay, and then we'll go back. Okay, we'll come back and then we reach the first element, and each time we'll pass through each element, we'll add that element to the new array. Okay, which we have created, as I've said at first. Okay, so that is how that is one way we'll reverse this array. And the second method is like we will like iterate through like there will be size of the array now. We'll iterate to half of the size of the array, and then we'll reverse it accordingly. Like we'll reverse the first element with the last element, second element with the second last element, likewise. Okay, so this is how we'll be doing. Yeah, so we'll use the second approach because the first approach means like we need to create a new array to store to reverse the array now. So that means like we'll use extra space. Yeah. So yeah, we'll start with the coding now. So like, yeah, sorry, I forgot to read the question. An array of type. So yeah, basically I'll summarize this question. So an array is given 1, 2, 3. We need to reverse it 3 to 1. Okay, like that. Different test cases will be. We need to pass different test cases. Okay, so and we need to print the array, print the reversed array. So let's all start. Yeah. So in this function, like a void reverse array, like the array to be reversed is also passed, and also the size of the array. Okay. So we'll start with the for loop. Int I is equal to 0. I is less than size by 2. Okay, since we need to iterate to half of the array only. Okay, the second half it will be automatically swapped. Okay, you'll understand the coming lines of code. Okay, so and also we'll declare a temp variable here to store like the swapping process. I'll explain it to you later. So int a of I and a of I is equal to a of size minus I minus 1. So this is where like it comes logical, like why we need to use I less than or equal to size by 2. Okay, so if we specify I is less than or equal to size, then it will like we'll get the same array as it is. Okay, so we need to, because it will like if we go to second half of the array, like it will like the array will be reversed again using this statement. Okay, this statement. So like that. So array of size minus I minus 1 equal to temp, because we are storing a temp variable. I mean, we are creating a temp variable because we should not lose this value. Okay, a of I, because here this a of I will be updated with a of size minus I minus 1. Okay, that is why you are storing a temp variable. Yeah, so I think that's pretty much it. So yeah, so let's submit the code. Yeah, so that's pretty much it. So hope you all understood it, this piece of code. Like if there is any doubt, do let me know in the chats. Can we just print the array in reverse order? Yeah, but yeah, the problem is like actually the question asks us like who asked that question? Yeah, can we just print the array in reverse order? Yeah, we can do that, but like actually the question is to return the, like there will be a function given, and like we need to return the array in reverse order. Okay, actually like we have used this language C++. So in C++ we like we cannot return an array from a function. Okay, Like for example, like this is a void function. If it's int reverse array, and if we type like return a, okay, a is the array. So this code will not work because for returning an array from a function, it's not possible. Okay, I mean it's possible, but it's some complex method is used, like using pointers and all. Like in Python and all, like I think we can use the approach you have followed. Okay, so Abhinav, I hope I have cleared that out to you. Okay, yeah, that's it. So now coming to like, okay, is there anybody who's not familiar with C++, but is comfortable with Python? Do let me know in the chats. Like if there's anybody like that, I can do it in Python too. Okay, Rian Gautam, are you not? You don't know C++? Okay. Okay. So yeah, we'll change the. So here, yeah. Oops. Yeah. So actually, I've coded this before, so the code has just popped up. Okay. So yeah. So this is the code. So like. Okay. So this is the code. So first of all, the math.floor, like math is a library, like import math. Math is a library which contains some functions. That function which we require is floor. Floor means like we need to get the least integer array. I mean, sorry, not array. I mean value not greater than x. Like here, like if we like, for example, if the length of the array, if length of a is 5, like if you do 5 by 2 in Python, we'll get 2.5 because there is no data, like we have not specified the data type. Like in C++ and all, if we write like int size equal to len of a by 2, then we'll get 2 because we'll get the it will like 2.5 will not be stored. Instead 2 will be stored. That decimal part will be removed. So but in Python it will be 2.5. So like a size cannot be 2.5 now. So like it should be an integer. So we like remove the decimal part using floor function. Okay. So yeah, that's pretty much it. So just to comment this code, can we write a YD? What? Okay, I think you're a pro. Yeah, len /2 also works. Yeah, that also works. Okay. Are you familiar with NumPy? YD? Like this code and all I have seen in NumPy and all. No. Yeah, I don't know from where did you get this code. Okay, so yeah, that's pretty much it. So yeah, so yeah. Now comes the for loop. So for I in range 0, size. So as we have seen in the C++ code, temp, like we'll store a of I in temp variable, then we'll swap it with size minus I minus 1. Here size is length of a, okay, not length of a by 2. Okay. So len of a minus I minus 1, and like we'll swap this, and then finally we'll return that particular this thing, particular array. Okay. So yeah, that's pretty much it. So you can run this code. Yeah, that's pretty much it. So this is the program for reversing an array. So it's a simple program now. So anyone not understood till now, do let me know in the chats. Like be it Python or C++, it doesn't matter. You can explain both of it. Why don't we write it in main instead of defining? Yeah, we can write in the main function, but like just I have like in sites like HackerRank and all, like they'll like the main code and all they'll provide, but they'll also provide a function to, like we need to fill the function only. Okay. So in sites like HackerRank, HackerEarth, CodeChef and all, like they'll provide only the function. So yeah, that's how CP works. So is it okay? Shall I go to the next question? Yeah. Okay. So speaking about the next question, it's a medium level question. The previous one was easy level. Next is the medium level. So yeah. So speaking about this question, so this like there will be given two arrays, and each array will contain a set of string values. Okay, like in strings array, like there will be double quotes AB, quotes AB, then ABC quote, like that. So you can see it from the question. And in queries and all, like queries array and all, it's same like that. So our goal is to like check for each entry in query, like for each entry in query, we need to check its frequency in strings array. Okay, so for example, the first element in queries, so A, B in quotes. So we need to check that the frequency of that element in strings array. Okay, strings array or list, whatever it is. So yeah, so we need to use again here for loops, but nested for loops, because for each element in queries, like we need to do it like check in strings array. So yeah, actually I actually thought of asking the approach to you, but accidentally I told the approach. Okay, so now it's no use. So yeah, so for I in queries, yeah, I think I said the correct method. So you have to calculate the frequency of each entry in queries by iterating through all the elements in strings. Okay, so yeah, so any other requirements we needed for this for solving this problem, like any variables or anything, do let me know in the chats. Yes, I think like we need a count variable. Yeah, so we need a count variable like to keep track of the frequency of each entry in queries. Okay, so yeah, so let's start with the coding for int. So let's start with the for loop thing. Yeah, size of here, the size of the string list is n and query list is q. Okay, so sorry, int I is equal to 0, I is less than. Can you do this also on Python? Yeah, sure. I'll do this on Python too. So I is less than q. So because I is less than q, like we are like choosing the outer for loop as q, because like the query is the outer for loop, because we need to check for each entry in query, like we need to calculate the frequency of each entry in query array. Okay, so that's why we have chosen the outer for loop as queries for queries array. So sorry, and also here inside this for loop we need to, as Adityan said, like we need to initialize a variable, like we need to keep a count variable for each entry in queries array. Okay, so now comes the inner for loop, which is for the string list, like for picking the strings. So yeah, int j is equal to 0, j is less than n, j plus plus. So yeah, so then we need to now check with each here. query list of I equal to query, sorry, not query, string list. Each element in string list, we need to keep track of that. And here a mistake can happen. So here, like query list, see the iterator of the query list is I, okay. So don't put here J, and here also don't put here I, okay. So here it's J. The iterator for string list is J, okay. So don't confuse with that. Yeah, so if this condition holds true, then we need to increment, okay. Count equal to count plus 1. And yeah, oh, also I have forgot to tell you one thing. Like the final answer should be the frequency of each entry in queries, okay. So there will be, we need to store the frequency of each entry in queries to an array, okay. So globally we have declared an array called result, like of the size 1000. So yeah, so we'll store the frequencies of each element in queries to this result array. So yeah, that's it. That's pretty much it. So yeah, so result of I. So the ith element will have, in query will have the frequency count. Yes, it's correct. So then yeah, I think that's pretty much it. Yeah, so that covers this question also. Yeah, so any doubt till now? I'll do this on Python too. So any doubt in the C++ code, do let me know in the chats. Like considering this example test case, like for this A, B, like just it appears 2 times in strings. So 2, ABC, it appears 1 time. So 1, and BC, it appears like does not appear in strings array. So it's 0. Okay, so any doubts, do let me know. Or should I proceed with the Python code? Okay, I think most of you have got it. So I'll assume like that. So we'll go with the Python code. Yeah. So in the case of Python, like in the C++ code, like there was a result array now to store the frequencies. But here we need not declare it globally. We can declare it locally, because the problem was that like in C++ code, yeah, C, in the C++ code, like we are not returning this function, okay. Like in that because like C++, as I said before, it's not possible to return the function, okay. So the function was void, so we need to declare a global array globally to store the frequencies. But in the case of Python, like the HackerRank asks us to return a function. Like they've defined a function, and like there's no problem in returning a function. So like to keep track of the frequencies, we have declared a count list array. And yeah, so this 0 to range will be from 0 to len of queries, and what is it? Then a counter for each and of j in range 0, len of strings. So if Yeah. So if queries of I equal to strings of j, oops, count equals count plus 1. So yeah, and at the exit of the inner for loop, we need to append it. So append the count to the count list. Count list dot append count. And at last, we'll return the count list. Class will return the count list. And that's pretty much it. Yeah. So we'll submit. That's it. So yeah, that's the medium level question. So for those who asked for the Python code, here it is. So yeah. So any doubts for this regarding this? Do let me know in the chats. Like it can be anything. Like if you haven't understood the concept or like the logic or whatever it is, you can ask me. It's okay. Yeah, maybe. Yeah, I think yeah, like we can maybe just pass through the list, but like that's a complex part. Like we are learning the introduction now, so like I've introduced the code through like the simple method. So any other doubts? Okay, so I think that's pretty much it. So yeah, so that comes to the end of the session. So thank you. Yeah, and also I'll give a few pointers about the competitive programming part. So like if most of you haven't started with competitive programming, so like you can all start with HackerRank first, then go to Code Chef, and then go to Lead Code finally. Okay, like I think most of you are first years and second years. So all of you, like please start with HackerRank, then go to like try doing Code Chef problems. Like one, like you can study the theory from HackerRank and then go to like Code Chef. Code Chef means like they provide a bit more tougher problems, and also like their problems are like math related. Okay, and also if you want to like in the higher level and all, like if you want to study about algorithmic problems, like you can go to Lead Code and all. Okay, so that's pretty much it. Yeah, that comes to the end of the session. So thank you all.
Hello, am I audible?
Yeah.
Yeah, okay. Thank you, Pranay. Sorry, Pranay, for a wonderful session on arrays and data structures. That brings us to the wrap. Don't go just yet. Just a few more things to say. First of all, we have our Discord server here, which I'm just going to put the link in the chat. So you can access this for more resources and for more updates regarding upcoming DS404 sessions. I think maybe there's a lot of theory being covered today, so you might want to you want to refresh that, you want to go through that again, all of that. I'm just going to share a link here. It'll also arrive via your mails, but just give me 1 second. Yeah, I'm going to put this link here. Yeah, right now. So this is the resources for today's session, which I've put in the chat. DS4042 resources. If you type in as DS4041 resources, you will get the access to the links of yesterday's resources, or you can check your mail if you've registered officially. Which reminds me again, if you want to avail those certificates, register officially. Okay. So with that, I think we can wrap up. Thank you, Pranay, for taking your time and preparing these slides and taking the session for us. Thank you all,
Likewise.
everyone who stuck by and actively interacted in the chat. That's great to see, right?
Yeah.
So with all that, I think we can wrap it up, yeah, officially. So
Yeah,
thank you for
and one more thing. Like I like to say about two books, like about CP, like
yeah. Don't leave
cracking
yes yet.
cracking the coding interview, and elements, like the cracking the coding interview is for Java, and elements in programming C++. Yeah, this was C++, like those who are familiar with C++. So do refer these books if you're not like familiar with the theory and all. Like, yeah, that's pretty much it. So thank you all for attending.
There's a test after the session, like you can access the test. It will be sent to you, or there's a do I put the mail here, or Bishop, anyone? I mean, do I put the link here?
Yeah, you can put the link here.
Yeah, okay. All right, the link is right here. I'm going to put it here right now. Okay. Yeah. And one more thing, again, the recorded video of session 1 is uploaded on TLE MEC's YouTube channel, so you can access that. Or also today's session's also been recorded and it will be uploaded soon, so you can cross-reference that and the slides at the same time. If you want, you want to hear Pranoy again with his beautiful voice tell you what arrays are, and refer our resources again. Yeah, so you can do that. The videos will be uploaded soon, so do stay tuned for that. Again, the Discord server, so join in immediately and get access. And with that, someone asked me, that is the Discord server link. Tomorrow, we have sessions tomorrow.
No, we'll inform about the future sessions soon.
Yeah, future sessions will deal with other things, more about Tom Vampire just played a terrible prank on me, which I'll be talking to him later. But yeah, future sessions will deal with stacks, queues in more detail and with questions pertaining to those in particular. Mohammed Satya, I'm sorry, I can't read your whole name, but yeah, that's a Discord link that I've sent to you. Okay, yeah, so you can access it to join the TLE server. So yeah, you can all begin to leave. Thank you for coming. Thank you for joining our session. Thanks a lot. Pranoy, you can stop sharing. Yeah.